Hello everyone, in this video I'm going to show you how to compute group frequency. Initially we saw how to compute individual frequency. For each individual score we calculated the frequency. Now we are going to group these values and then we want to calculate the frequency. Why do we need to do that? Because if you notice, the values that we obtain here can be from as lowest as 53 to highest as 94. So what happens here is you have a long list of values, potential values between 53 and 94. So it is not practical for us to list each and every value between 53 and 94 and count the number of times each score appears. So what will be the best alternative? We combine them, we group these values into a possible classes, possible groups, and then we count how many of them in that particular group. So what will be the first step? Estimate the range of the score. Range of the score meaning the difference between the high and the lower score. So identify what is the highest score. Our highest score here is 94. What is the lowest score? Is 53. So when you subtract 53 from 94, you get 41. So 41 is the range of the score, meaning there are 41 different values, that is within this particular score that we have received. So it's not practical to list 53, 54 until 94 and then calculate, because sometimes there is also no value, so there is no scores for that appears in this data. So if you notice, there is no 81. So if we want to list every score in here, some scores doesn't even appear in your data, so it is not practical. So once we got our range, next is to determine the number of classes. Number of class meaning number of groups that you want to group them. Okay, using 2k rule. Okay, so 2 to the power of k rule. So now let's look how to calculate, how to estimate the class. Within the estimating the class, there are 3 steps. Okay, so first, A is count the total observations. So how many scores or how many information that you have, observations that you have. So you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. So you have 25 observation. Next is use the 2 to the power of k rule for identifying class. So what you need to do is pick a k where the value exceeds the sample size or the total observation. The total observation that we have is 25. So what we do is k is actually number. So from 1 to it can go up to any values. So what we do is we find 2 to the power of k. So if k is 1, 2 to the power of k is 2. If the k is 2, 2 to the power of 2 is 4. So when you calculate, 2 to the power of 5 is 32. And these 32 exceeds the value or total observation of 25. So what we do here is we take the k equals to 5. Okay, so meaning that we can group the values into 5 potential categories. Okay, so what will be the third step? Is to calculate the width of the classes. Now we know that we need to have 5 groups, 5 classes. But now we need to know what is the width, the interval between the group scores. So how do we calculate that? So we get the range plus 1, divide them by the number of groups or number of class, which is k. So we got the range just now, 41. We add 1. And the total will be divided by 5. So the value that we get is 8.5. So what we do is here for classes, we usually rounded it up to the bigger number. So 8.4, so approximately 9. So we use the width to create the grouped frequency. So what was the lowest score? 53. So from 53 we add 9, you get 62. So this is the first group. So what will be the second group? 62 plus 9. So will be 71. 71 plus 9. So you will get 80. So when you do that, you will get how many classes? 1, 2, 3, 4, 5. So you have 5 classes. All the data that you have, all the numbers that you have received before will group into here. Maximum, because here is 98 and our maximum, the highest score is 94. So it can fall into this particular group. So if you choose k equals to 4, you will leave out the value of 94. So that's why it's important to get number of classes that is bigger than the value from the number of classes. Sorry, the number of 2k rule should be greater than your sample size. Okay. Now, once you get these values, once you get the classes with the intervals, you can compute the frequency. So what you can do is you can find values from within 53 until 61. And then you count how many values are there from 62 until 70. Then for the third class is from 71 until 79. So the case of 80 until 88. And here will be 89 until 97. So we count how many of them occurs. So where do we count that from? From this previous value. So from 53 to 61. So we calculate 1, 53, 58, 2, 3, 4. So you will get 4. So we do that for every class. Then when you add all this frequency, you will get 25 because the total observation that we have is 25. Okay, you would have been noticing why 62 until 62 here, and then I repeat again 62 here. If you remember lower bound and upper bound, okay, so lower bound is inclusive. So we include, when you are computing frequency, we include 53 until 61. 62 is excluded because it is included in the second category. Okay, so that is why the 62 appears twice, 71, also 80, okay, and 89. So basically here we include 53 onwards until 61. 62 is actually inclusive of here, 62 until 70. So 70 and 71 until 79. So that is what we mean by the lower bound and upper bound, the inclusive and exclusive values. Hope it was clear. Thank you.